And welcome back. In this last tutorial of the tutorial series, I'm going to show you how to create these last two sections of your decentralized application with the Python front end in Dash. Now, these last two sections will actually allow the user to extract data from the blockchain, right? To pull data from the blockchain, in which case you only need to use Python, and this is going to be done on line 359 with this callback, and then on line 402 with the second callback, right? These two correspond to these two sections. So the first section here, we're going to allow the user to put in an ID, an integer, and then hit the submit button, and it will pull the corresponding shelter from the blockchain. In this case, the last callback is going to pull shelters that are at capacity false. It's going to create a dash AG grid table only with those shelters where at capacity is false, meaning they are open to receiving more animals. So if I'm a shelter and I need to send my animal somewhere, or I found an animal and I need to on the street and I need to give it to a shelter, I can use the blockchain to see which shelter is not at capacity and can receive more animals. You can even move these columns around. It's kind of cool. So how do we do this? Let's go into the third callback called, let's see right here, on line 359. Now, a callback, a server-side callback in Dash is one of the most popular callbacks that you're going to see. You're going to see this 90% of the time. It's very similar to the client-side callback that works in the browser. You see we have outputs and inputs and states. But instead of a function being declared in JavaScript between quotation marks, the function is declared in Python with the inputs are arguments and then the object, and then it's executed here, and the object is returned at the end. So this is the only difference, how the function is, the callback function, how it is written out. But similarly, they all have output, inputs, and state. So in this case, we're going to have the end clicks as the input that will trigger the callback. Remember, every input argument will trigger the callback. So every time this button is clicked, it actually triggers the function and returns a result. This state is also an input, but the difference is it doesn't trigger the callback. So this value of single shelter ID, if you look for this, Control C, Control F, if you look for this, you'll see it in the layout. This ID corresponds to the Dash Bootstrap input component. This is this field right here, the input field, all of this. And this input field starts with the value 0 when the app first loads, and then 0, and then as soon as the user changes it, it updates. Obviously, the value of the input field is updated. So in this case, we'll take this value, which is 2 or 3 or 4, and we're going to pass it as an argument inside our function. Okay? So we have our end clicks, and then we have the value or the ID that the user wants to look up. And now that we have that information, we have to connect to our contract. So first, we're going to get our zkEVM RPC, which helps us connect to the Web3 HTTP provider. So we're connected to Web3 W3, which allows us to pull information from the blockchain. If you're on the Sepolia blockchain, then you'll have to use a different Sepolia RPC. In this case, our contract is on Polygon zkEVM, so we're using this one. Then we need to connect to our contract in order to connect to in order to trigger a function that will pull data from the database, right? This is our contract. So we need the contract address that you should already have by now because we talked about this address in every single video. And then we also need to pass the ABI, which you already have as well. Just as a reminder, in every smart contract on Remix, you can get the ABI right here from this button right here. As soon as you save your contract, you go to compilation, the compilation icon, and then you can get the ABI. So we have the ABI, we have the contract, and now we created an instance of the contract. And now that we have our contract, we can call a certain function. In our case, we are going to call the getShelterListing function. Why is that? getShelterListing function in our smart contract on line 141 is a function that allows us to query the blockchain and just pull corresponding shelter, the corresponding shelter from the right ID. So this is going to return a shelter listing. This is the mapping. Let's go back to shelter listing, shelter ID. You see that if you go to line 52, a shelter listing mapping, which is very gas efficient, is a very good data type to have to pull data from the blockchain. All you have to do in this case, we feed it an integer, which will be our shelter ID, and this integer is going to return the corresponding shelter struct. Okay, we have shelter listing with 10, 20, 100 different shelters in there by shelter ID. All right. So going back to 141, we have to give to the getShelterListing function, we have to give it one argument, which is the shelter ID. So make sure you do that in your Dash app. We have to give it the shelter ID. In this case, it's the value, or we could call it ID as well. See, this value corresponds to the value of this input field right here. This is the ID. So once we have our ID, we pull this information, and we know the shelter struct has 7 different variables right here. As soon as we get the shelter struct back, it's given us 7 different. It's going to give us 7 different variables in this order. So make sure you have the right order of the variables. And I'm just returning the result in a nice way, in a kind of like a multi-line. You see right here, name, country, city. So all I'm saying is create like multiple strings, multiple lines, and each row in each row say name will equal to the name variable of this information data that was pulled from the blockchain, country, zip code, and so on and so on. So you end up with 7 different variables in the shelter struct that you can see. Now, this is the callback that will pull information from from the blockchain. Now, one thing I forgot to tell you, this is the result. Then we return this result as an object to the component property of the output. So very similar to the client-side callback. If you have 2 outputs, that means you have 2 component properties, the children of this ID and the children of this ID, of this component. And if you have 2 component properties, you need to return 2 objects. The second object is no update, which is right here. No update will be assigned to children of the loading form, because this is just responsible for the spinner. You see the spinner, so we don't need to update it. We'll just keep it there. Just allows us to have a spinner when the button is clicked. And the first object that we return is a result object, which is this string right here in multiple rows, and this is returned to the children of this component. Let's see, Control C, Control F. This component in the layout on line 360, line 297. This is an HTML div, right? So all we're doing is we're returning the result to the children of this HTML div. All right, so we finished our callback that gives us information from the blockchain. This last callback on line 402 is a bit more complex. It's a bit more advanced. In this case, we're going to comb through all the log events and only return shelters where add capacity equals false. Now, I'm gonna teach you this, although it's a bit more advanced, so you know what's going on, and hopefully you can do something similar in your dApp. But what I did here is I decided to comb through all the log events, all the event logs of ShelterInfo. Remember that in our smart contract right here, we create an event called ShelterInfo with like 4 different variables. And we emitted this event in 2 occasions. When the shelter was added, a new shelter was added, at the end we emitted this event to the logs of the blockchain. And we also emitted this event in the update shelter function twice. I decided to emit this event twice. So anytime somebody added a new shelter to the blockchain, or they updated their shelter like a week later or a month later, this event was added to the blockchain, which you can see if you go here, you go to this hash, and you can see logs. These logs are actually events. See, 4 different variables, because the event has 4 different variables, right? Every log event, except for the first one was just building the contract. This has no log event, but all the rest have log events that correspond to the ShelterInfo event. So what I did is I went through all the events and I removed the duplicates. I only kept the unique events, right? Because you'll have many duplicates. You'll have somebody put in shelter 1 from New York City, and then a month later they updated their shelter 1 from New York City to be deleted or at capacity true. So that's already 2 events. After 2 months they updated their shelter again, so that's already 3 events with the same shelter ID and most likely the same shelter name. So we don't want duplicates. I'm going to go through all the events and only keep the unique events, the unique shelters. And once I have those shelters and the ID of each shelter, then I'm going to get that shelter struct or all that shelter information from our smart contract, from the getShelterListing function in the in Solidity, in what we build in Solidity. I think this is faster, but you can experiment with this when you become more advanced. If you choose to go through to search all the blockchain directly through the getShelter function instead of going through the logs first, definitely feel free to do that and see if it's faster. I think this was faster. So let me explain the code. Here, I'm doing the same thing as above. I'm connecting to our Web3, getting our contract address, the contract API. Now we have our contract. Now that we have our contract, I'm going to go through the logs of the ShelterInfo event, but specifically from this block to this block. You can see right here block numbers, this block to 22251521. I'm going to go through all of these blocks because we can also do a latest like this, and it will go through the latest block. But in a year from now, this latest might be block number 3,200,000, and that's a lot of blocks to go through. So I just limited it to this last block number that I know of. Now we have it's going through all the events of these blocks, and then what we're going to do with this part right here, we're going to generate a dictionary that only has the unique shelters. Because remember, we have multiple events for each shelter, but we only want the unique shelter of the last event. So if I put shelter number 5 from Dallas, Texas, and then after a month I updated the capacity, and after 2 months I updated the zip code by mistake, then, well, not by mistake, I have a new zip code and I updated it. I only want this last event, which has the most accurate and most up-to-date information. So this is what I'm doing here. I'm going through all the shelter, all the events. I'm going to dig in through the logs that we have, and I'm going to say if the shelter does not exist in this dictionary, if it's the first time we enter the shelter, we see the shelter, then put it into the dictionary. Or if the block number of the shelter ID that already exists in this shelter is smaller than this current block number of this current shelter, then we know then this current shelter is the most up-to-date and most recent one, so add this shelter to the dictionary. As a result, this is where you add the shelter to the dictionary, we have our most recent shelters, right? And unique, most recent and most unique, not most, but unique shelters. And now that we have our unique shelters, now we can compare it or map it to the getShelterListing function. Remember the getShelterListing function right here, line 141. You need the shelter ID, and it will give you the mapping of that shelter and shelter ID. So it will give you the shelter struct. So you just need to give it the shelter ID. And now we already have the shelter IDs right here. We don't even need the block number. We have the ID 1, 2, 3, and so on and so on. So I'm going to say go over every ID in this latest shelter events in this dictionary, or every number, and then pull this function of getShelterListing function with this ID, right? This is from the Solidity smart contract. So now we have a shelter struct corresponding to this ID, and here I'm going to use a list and some formatting of a dictionary to actually filter out shelters that are at capacity, right? And you can, if this is, you don't understand what's going on, I recommend like adding print functions. Go like print, and then we'll do print ID of shelter, right here. And then you can add another print after you do this. Print this new list, shelter ID list. And by doing so, it's going to allow you to understand what's happening inside this function. All right, submit. You see now it printed a few things out. All the way down, right here. So it printed number 1. This is the ID. Then it printed the list, right? This list right here, a list number 1. In the second loop, it printed ID number 2, but it didn't print any list. And why? Because it jumped to the third. It went over the whole loop and then it jumped to ID number 3. Because in ID number 2, the shelter data at capacity equals true, right? The shelter's capacity, so we're not appending it to the new list, right? So there's a lot going on here, but if you add print statements in between, it's a lot easier to understand. Once we have our shelter with capacity final list of dictionaries, we're going to take this list of dictionaries and put it, create a pandas data frame out of this list. And once we have our pandas data frame, we're going to incorporate it into our -AG grid, right? As row data and column information. These are the headers. And we return this grid as an object to the children of our second HTML div in the layout. And that is how you get this AG grid table inside this HTML div. Right now you can see, you can try and experimenting. You can go into shelter number 2, and you'll see that at capacity is true, so that's why it's not here. Shelter number 2, see? But you can go and try and updating shelter number 2 to be at capacity false, and you'll see that you will get here this shelter in this table because it has capacity to receive animals. So I know this was a lot, especially this second part, the second callback. What I'm going to try and do is create more tutorials to help you better understand how to pull data from the blockchain. But if you have any questions in the meantime, definitely ask me those questions in the comment section of the video. I'm going to try my best to educate you and learn how to build decentralized applications with Python. Always remember, we're better together, so help each other out. If you like this video, click the like button, subscribe, join, become a member. Everything you want to do to support me, that'll be great. Have fun. Bye-bye.